Hello everyone. Now in this tutorial we are going to go into the simulation of Hatchetman Attack, which is another type of attack on this Ripple protocol. Ripple, we all know Ripple standing for Routing for Low Power and Lossy Network Protocol, which is a routing protocol that is used in this Contiki that is used in Internet of Things operating system. So basically a routing protocol that is used in IoT by IoT devices, and also it is being implemented in the Contiki operating system. So what is Hatchetman Attack? Hatchetman Attack is a kind of denial of service attack. It was first presented by Fu and Song in 2018. So basically in the attack, a malicious node abused the source route header of the received packet packet to create and propagate a huge number of invalid packets with error routes to non-malicious node in the network. So as a result, the benign node cannot relay the packet, which brings about a DOS attack and reply a large number of error packets back to the sink, thereby eating off communication bandwidth and not energy. Hatchetman Attack is a disastrous attack rifle network according to simulation results shown by Fu and Song 2018. So Hatchetman Attack results in a large reduction of packet delivery ratio and additional power consumption according to Sharma et al. 2022. Hatchetman Attack simulation in Cooja Simulator from Contiki is achieved by making modification to riffle.icmp.c. Actually, this dot doesn't exist here. It's just riffle-icmp.6, which is a file used in the implementation of Riffle protocol in the Contiki operating system. So this is an algorithm of the Hatchetman Attack. And the goal of the Hatchetman Attack is to cause high-frequency error propagation. So while the Riffle routing protocol is in the downward stream mode of operation, that is, the mode of operation is downward. That is the path that the packet travels is in the downward direction, not in the upward direction. And the mode of operation is non-storing. Riffle has two modes of operation: storing and non-storing. We know that in the non-storing, that is when the Riffle use source route header, whereby the route that the packet is going to pass through, it is being written in the source route header, so that when a node passes a packet to another node, the next node will just look at the source route header to know the next destination of that particular packet. So what happens is that a malicious node is going to eavesdrop the source route header. It's going to look at the source route header, and if address bit is present, it's going to fetch the address bit field and it's going to remove some addresses from the address sequence and then add an unreachable address in the address field, and then forward the manipulated packet so that the next node or the series of nodes that are in that particular path will not know. When they see that particular bogus address, that is the fake address, they will not know where to forward the packet to, because there's no any node within that particular network that has that particular address. So therefore, they don't have any option than to drop the packet. So that is basically how Hatchetman works. This particular, we can also see it here in this particular illustration here. So we have source routing, and then we have a root node. Then the root node passes a packet to node A. Then node M happy to be the malicious node. And so after receiving a normal packet from node A, it is going to perform the Hatchetman attack and then pass it to the respective nodes after it: node B, node C, node Z, node D, and node E. And then, as we are going to see also in this particular illustration, which originally is the source of this illustration is from Sharma et al. 2022, we can see a packet. Originally, the packet has RAMBCDE, and that is in its source route head, meaning that the source of this packet is node R, and the final destination of this packet is node E. So it passes from the root node, which is node R, to node A, then to node M. Now node M happens to be the malicious node. So it's having to be the malicious node. Is going to add a fake address. So we can see packet RAMB now is going to add a fake address after node B. and then pass the packet to node B. Now node B will not know which node has this address F. There's no, because we don't have any node F here in this particular network, as you can see. So therefore node B don't have any option than to drop the packet. Also another packet, another bogus packet, pass it to node C that has a fake address after it. So node C will not have anything, will not have any option than to drop the packet. Likewise node D and node E. Node E. So here supposed to be actually supposed to be RAMBCD. It's supposed to be E. So after E, you're supposed to this has been repeated twice. Actually, this has been repeated twice. It's just a duplication of it. And this particular paper where I'm reading it from is my paper where I'm preferring, where I'm proposing a solution to this particular Hatchetman attack. It is still a research in progress. Efficient resolution of Hatchetman attack, a routing for low power and lossy network riffle using 2-ax scheme. You can find the paper in ResearchGate. So you can search for ResearchGate and get this paper and look at it proper. Okay, so now we are going to go to Contiki operating system, and then we are going to simulate this particular Hatchetman attack. So for details about the simulation, all the things that I'm going to explain in this particular video, you are going to get it from my book that I publish here. On you can get the book from Amazon. That is, if you need a paperback, you can get it from Amazon. Simulated routing for low power and lossy networks, protocol attacks, a comprehensive guide for researchers. You can get it here on Amazon by Faisal Garba. You can see it here on Amazon. You can get it on Amazon, or if you prefer the ebook, you can get the ebook on Sailor. You can get it on Sailor, and then you can just pay for it and get it and download it immediately. It comes with the source code. So all the source code that I'm going to use here, you can get the source code. So as soon as you, especially the ebook, if you pay for the ebook and download the ebook, it comes with the source code. You get a zip code, a zip file that contains the ebook and the source codes. Likewise, if you purchase the ebook, you are going to get a link that you are going to click on the link. You are going to write the link on your web browser and then visit the link, and you are going to be able to download all the source code. So all the source code that I'm going to use here are going to be made available when you buy the book. So you try to purchase the book and support the author so that I can be able to do more for you. Okay, so now we move to the Cooja Contiki operating system, and then we launch our Cooja Simulator. So I'm going to CD Contiki 3.0, Contiki 3.0, and then go to tools, and then go to Cooja, and then I'm going to clear my screen so that I can have a fresh terminal. All right, so I'm going to issue the command sudo and run, and I'm going to hit enter. Then I'm going to enter my password. So the Cooja is going to launch, and then I'm going to, first of all, what I'm going to do, I'm going to do two types of simulations. I'm going to do a reference simulation, and then I'm going to do an attack simulation. So the first simulation is going to be reference simulation, where we have all the nodes are going to be benign nodes. All the nodes are going to be benign nodes. All the nodes are going to be benign nodes. That is, in that particular network, there's no any attacking node. Then in the next, so that then we study it. Then we moved and do the simulation where we introduce the malicious nodes, and then we have two types of simulation. Then we compare between the two. So the reference simulation is going to be a kind of baseline simulation that we are going to compare against a simulation that contains malicious nodes. Okay, so I'm going to do here, I'm going to compile new simulation. So I'm going to launch a new simulation. I'm going to call it reference simulation. Reference. So let me just call it a reference. Or if I like, I can name it as ref sim or reference simulation. Okay, or reference. Don't let me just leave it as reference. So I'm going to create. Okay, next, so I'm going to go under mode, add mode, create normal type, and then I'm going to select sky mode. The next, I'm going to browse. I'm going to go to my Contiki 3.0 here. I'm going to go under examples. I'm going to go under IPv6, and then go to riffle UDP, and then I'm going to go select UDP server.c. Okay, open it, and I'm going to clean. I'm going to compile. So I'm going to simulate 40 nodes. 40 nodes. So I'm going to have 40 IoT nodes in this particular simulation. So this is going to be like our sync node, our root node, the server. So I'm going to select it, add it to this network window here. So I'm going under view here. I can add mode type to differentiate between the different types of modes, and then I'm going to also view the address, IP or Okay, so what I did here basically, I just add to mode type and then address is IP or okay. So I say I'm going to add 40 nodes. So I have one already. Now I'm going to add 38 sender nodes. So I have one server node. I'm going to add 38 client node. Then the 40th node is going to be a node that is going to be in charge of calculating our network performance metrics. So that it's going to calculate the network performance metrics. I coded it. When you buy my book, you are going to have that particular code that will be responsible for gathering the network metrics, the PDR, packet delivery ratio, end-to-end delay, energy consumption. So all those network performance metrics, we are going to do them. We are going to compute them. You are going to see it here realistically. So now I have this. I'm going to add 38 sender nodes because we have one already here. So 38 plus 31 make 39. Then we add the final, that particular node that I said is going to be in charge of computing the network performance metrics. So I'm going to go to here, mode, add mode, create new mode type. I'm going to select Sky mode once more, and then I'm going to go browse. And this time I'm going to select UDP client.c. I'm going to open it. I'm going to clean, and then I'm going to compile. So it has finished compiling. I'm going to create. Then I'm going to add 38 as I said. So 38, add 38 mode, 38 sender mode. So I have added 38 mode to the network environment. Now next, I'm going to add that particular mode that I say is going to be in charge of gathering, computing the network performance metrics. So I'm going to scan Sky mode, and then I'm going to go browse. Then I am going to go, I have it here in this particular folder. Within examples, I have it here, gather analytics. That is what I named the folder. And then I have it as Contiki app.c. So I'm going to select it. When you buy my book, you are going to have access to this particular code so that you can also use it and replicate this simulation. So I'm going to compile, and then I'm going to create. So I'm going to add just one mode here. So you can see it here. It is here. It's going to be in charge of computing the network performance metrics. Now, final thing, I also need to capture FAQ files. Now, FAQ files will be, I'm going to make use of the FAQ files to compute the packet overhead. We know that a ripple network, we have the control packet, the DIS, the DO, and the DAO. We know the DIS, the DODEC information solicitation packet, and the DAO, the DODEC advertisement object, and then we have the DO, DODEC information object, and the DODEC advertisement object, DAO. We know that those packets are responsible for the controlling the operations of the Ripple protocol. They're in charge of when a new node wants to join the network, it sends a DIS packet, and another node can reply to it with a DO packet, DODEC information object, okay, to enable the new node join the network. So you're familiar with Ripple operations, how Ripple works, okay. So now I'm going to go here. What I'm going to do to be able to capture the FAQ files, let me call it, make sure that I'm pronouncing it correctly, FAQ. So call it FAQ files, FAQ files. Okay, so what I'm going to do here, I'm going to do under tools, I'm going to radio messages. So let me bring it here. And then I'm going to select analyzer. I'm going to select syslofan analyzer with FAQ. Syslofan analyzer with FAQ. So everything is set. I'm going to now launch my simulation. I'm going to run this simulation for 10 minutes. So I'm going to run it for a total of 10 minutes. And then after that, I'm going to stop the simulation. So I'm going to click on start. So this is by my time, it is 10:29. So I'm going to run it for 10 minutes. So let me start. So the simulation has started running. This is a reference simulation. In this particular simulation, there is no any malicious node in this particular network. So we haven't started seeing any radio messages in this particular. Okay, so they have started coming. They have started coming. You can see packet radio message showing, you know, those number of packets. Okay, so we are going to run this simulation for 10 minutes. So this is 10:29. So that means we are going to stop when my time says 10:39. So by 10:39, I'm going to stop. So I'm going to pause the video so that to make the video not long, to shorten the video, I'm going to pause the video so that when it is 10:39, then I'm going to resume, and then we perform the next simulation, which is the Hatchetman Attack simulation. So let me go and pause the video. All right, so it is 10:39. Remember, we started the simulation at 10:29 by my time, Nigerian time, July 14th, 10:39 p.m. 10:29 p.m. That's when we started. So it has run for 10 minutes, as I said. So it is 10:39 now. So I'm going to stop the simulation. I'm going to force the simulation. I'm going to click on this button, force, to pause the simulation. So I'm going to save my log. So I'm going to go here under the mode output. I'm going to click on this file and this saved file. And then I'm going to call it reflog.txt. So I already have something here similar to it. So I'm just replace it with that particular name, reflog.txt. I'm going to save it. Overwrite. Yes, overwrite. So I want to overwrite that. Okay, so I've saved it. I've saved my FAQ files. My log files. Now next, I need to also get a location where my FAQ files are being kept. So by default, they are kept in the directory where I launched my Cooja. I launched my Cooja from Contiki 3.0. So I'm going to Contiki 3.0. I'm going to go under tools. I'm going to go under Cooja, and then I'm going to go under build. And then I'm going to have my FAQ files. So I have several FAQ files. I'm going to locate the one that I did today. I'm sure it should be this one. So I'm going to just look at the properties. This is July 14th. Let me look at the one next to it. Properties. Network packet. 154139. July 13th. Okay. Why am I having several FAQ files? Okay, let me look at this one. Properties. July 14, Sunday. Okay, I'm sorry. Let me look at it. 23:59, July 12, Friday, July 12. Size. Normally, I should just have one FAQ file. I don't know why I'm having several, and they are all reading. Okay, modified on July 12th. This one is on July 12th. This one is an old one. Let me delete it. And then let me see this one. July 14th, July 14th. This is July 14th, 2396. Let me look at this one also. July 13th. Okay, this one was yesterday, so this is an old one. Modified so to July 13th. It's created July 13th, so I'm going to delete it. This one. Now let me see this one. Properties. Or modified on July 12th. On July 12th. Look at it. That's when it was created, July 12th. So I'm going to delete it. So this is the actual FAQ file that was captured in this particular simulation. We have it July 14th, accessed July 14th, and modified on July 14th. It was, by modified, it is created on July 14th, and it has the highest size, 3.3 MB. So I'm going to rename it as ref.FAQ, or just ref.FAQ. Means reference simulation.FAQ. So ref.FAQ. I'm going to move it from this particular folder. I'm going to Control X. I'm going to come here under Documents. I have here YouTube, where I'm giving the files, Hatchetman, and reference simulation. I'm going to keep it here, ref.FAQ. Okay, I'm going to, this is an old one. Okay, so let me go through properties, make sure that it is the right one. Properties 3.3 MB, it is the right one. Okay, so now we are going to do this Hatchetman Attack simulation next now. So I'm going to go to my Cooja. I'm going to create a new simulation. Actually, I'm going to exit this particular, I don't know why the Cooja usually gets overloaded, because I put almost 40 nodes. So I want to refresh the Cooja simulator completely. So I want to exit and then relaunch the Cooja simulator so that it's going to start afresh. I'm going to start fresh without having anything in this memory. So I'm going to exit. Do you want to say no? I don't want to set any current simulation. No, I don't want to set any simulation. So I'm going to go under my here, under the terminal where I launched the Cooja. I'm going to clear my screen, and then I'm going to relaunch the Cooja again. Perfect. So now I have my Cooja. I'm going to come under new simulation, and then I'm going to call it Hatchet Man. Hatchet Man. All right. I'm going to create it. So next, I'm going to go under mode, add mode, screen the mode type. I'm going to select sky mode. Browse, and then first of all, I'm going to put 40 mode also here, 40 modes. And then I want to make sure that 30% of the modes are malicious. 30% of the mode, I want 30% of the mode to be malicious. So altogether, the benign mode and the malicious mode making 40 modes. So 30 of 40, what is it going to be? Let me go to my calculator. It should be 12. Well, let me make sure that I'm computing the right thing. 30% multiply by 40. What do we have? So we have 12 modes. So I'm going to add 12 malicious modes to the network. So I'm going to add 12, 40 nodes altogether. 40 nodes. 12 of the nodes are malicious. 12 malicious modes. So I'm going to have 12 malicious modes. Nodes. So I'm going to come here. I'm going to come under mode, add mode, create new mode type, sky mode. And then under browse, I'm going to go to some examples. I'm still in this Contiki 3.0 because I want to put the benign mode first. So IPv6, Ripple UDP, and UDP server. So I don't need to compile this. I already have it. I compiled it in the previous simulation. So UDP UDP server.sky. So I'm going to select it. I'm going to create just one. That is the server is going to serve as the root node. Mode type. I want to know the mode type. I want to view the addresses, the IP addresses of the mode also. Okay. So next, I also want to add the benign sender modes, the benign client nodes or modes. It's all the same thing. Modes or nodes, all the same thing. So out of 40, if we remove 1, we have 39. So 39, when we remove 12, 12. So 40 minus 13, what do we have? 40 if we minus 10, we have 30. 30 minus 3, we have 27. It's 27. So I'm going to add 26. So we have okay, let me see. So I'm going to let me go to my calculator so that I won't make any mistake. Let me go to my calculator once more. So I'm going to have my calculator. I'm going to say 40. I have one sync mode. I have 39. 40 minus 1 is 39. So minus the malicious mode that I'm going to add is going to be 27. 27 minus 1, that mode that is responsible for computing the network performance matrix. So I have 26. So I'm going to add 26 sender modes. So I'm going to add 26 client nodes. So I'm going to select UDP client.sky. So I'm going to select it. I'm going to add 26 of it. 26. Add modes. Okay, so I now have altogether, I have now 27 nodes. Then that node that is responsible for computing the network performance metrics, I'm going to come here, Sky mode. I'm going to browse. I'm going to go under examples directory, Garba analytics. I'm going to select it here. So also it's already been compiled in the previous simulation. So let me just Contiki app.sky. So I'm going to select it and then create and then add modes. So I have it here added to my simulation. So the next, I need to add now the malicious Hatchetman attacking modes. So I'm going to add modes, create new mode type, Sky modes. So I'm going to go browse. I'm going to go and add the malicious modes. So it's under here. I have them here. Rifle attacks, Hatchetman. So Hatchetman, and then I'm going to go Hatchetman. So any node I compile from this particular directory is definitely a malicious Hatchetman attacking node. So rifle UDP, open. Then I'm going to select UDP client.sky. I'm going to open. I'm going to add create. I'm going to add 12 of it. As we said, we have it here. 30% of the 30% of 40 is 12. So I'm going to add it. So I've added the malicious mode to my network. So I'm going to, okay, then we need to also capture packets that we are going to account for the control overhead. So radio messages. Then I'm going to select analyzer and then slow fan analyzer with backup. Then I'm going to start the simulation. Simulation will run for 10 minutes. So this is 10:50. So by 11 o'clock, I'm going to stop the simulation. So by 11 p.m., I'm going to stop the simulation. So I'm going to stop it by 11:00 p.m. So I have it here. Let me bring this one here. Let me, so that I can observe the output clearly. Let me move this one here. That's all. So you can see the printout from the mode output showing rifle event. Parent has been added. A new parent has been added to the DAG. Parent change. Stable route duration. This printout was added in the Hatchetman Attack malicious node to be printing all these rifle event. So we see Hatchetman Attack detected. Manipulated prefix to fictitious address. I find Hatchetman Attack has occurred. Also likewise here, ID node with ID 37 has performed an Hatchetman Attack. So same node, Hatchetman node with ID 37 has performed a Hatchetman Attack. Also likewise here in the same thing, it has also performed an attack, Hatchetman Attack. Excuse me. So I'm going to, in order not to make the video long, I'm going to pause the video. Remember I said if you all these details is going to be added, including the code. You're going to get all the code and the details from my book. So try to get a copy of the book. To get the copy of the book, you go to Amazon. Go to Amazon. Here, Simulator Routing Follow Power Alerts Network Protocol Attacks. You can get the paperback. If you want the paperback, you can get the paperback from Amazon. But if you want the ebook, you can get the ebook from Sailor. So you just come here, sailor.co, and then you can buy the ebook. And both of them, the paperback, when you buy the paperback, you have a link that you can type in your browser's address bar here. Type out the link, and then you'll be able to access the code. And then when you buy it, the ebook from the seller, it comes bundled as a zip file with the codes. So you get all the codes. All the codes that I'm using here on this particular simulation in this video. When you buy the book, you are going to get access to the codes. So I'm going to stop the simulation so that not to make the video very long. By 11 p.m. I'm going to resume and pause the simulation. So let me go and pause the video. So it is 11 p.m. Well, the right time for us to stop this Hatchetman Attack simulation. So I'm going to force the simulation. And then I'm going to save my log. I'm going to come here, save the file. I'm going to save it as attack.txt. Attack.txt, that is attack log or attack log.txt. Make it attack log.txt. So I'm going to save it. Now next I'm going to go under my under my Cooja, that is the directory where I launched Cooja. I'm going to go under home, Contiki 3.0, tools, Cooja, build, and then I'm going to have my backup file. So I have it here. I'm going to name it as attack.backup. But I name it as attack.backup. Perfect. So I'm going to move it from here, attack.backup. I'm going to go under documents. I'm going to go under YouTube, Hatchet Man, and then attack. I'm going to paste it here. Then under the log, the attack log, I have it here. Okay, so I have two folders, attack log.txt. I'm going to cut it. I'm going to move it to the right folder. So attack, paste it here. So I'm going to move over to my this is my guest operating system. I put Contiki as a guest operating system in my in a virtualization machine. So I'm going to go over to my host machine where I have a Python file that I'm going to use to analyze this log and the backup files to compute the network performance metrics. So I'm going to the whole of this folder Hatchetman. I'm going to copy it. I'm going to go to my shared folder here. Okay, I have already one Hatchetman. Okay, so to avoid confusion, let me Hatchetman, name Hatchetman files. Let me call it Hatchetman logs. So let me copy, come to shared folder here. I'm going to paste it. Then I'm going to go over to my parent Windows something. So I'll come here, home, virtual machines, Contiki 3.0, come to shared folder. I'm going to Hatchetman. So let me copy it. So I'm come over here. Where am I doing this thing? Videos, YouTube, Hatchetman. Okay, so I have, this is where I have my analyze. This is the Python file that I'm going to use to analyze these logs. So I'm going to open it, this particular Python. Let me open it with Sublime text editor. That is my favorite text editor. Okay, so I have this. So here I'm going to replace log file with attack. I'm going to put I'm going to replace this with the appropriate files that we collected from our simulation. So I'll just come over here, Hatchetman logs. So come to the reference log here. Anyone, you can start with anyone. So I'm going to Control L and just copy the path, the absolute path. Come here, come to here, and then log file with attack, log file without attack. So it's going to be here. So I'm going to clean everything that is here. .txt going to be here. I'm going to paste it. Okay, I'm going to replace it with the name of the file proper. So the next one here, I can just replace it with the name of the file is proper. So I'm going to just come over here, move. Okay, so here, paste. then I'm going to replace it for the name of our package file. So come over here, go back to the directory. The name of our log is reflog.txt. Reflog.txt. I'm going to copy the name reflog.txt. So come over to my this is where I have it .txt. I'm sure the other one I named it as ref.fuckup, ref.fuckup. Okay, then for the attack log file and the fuckup, I'll move over to the respective directory. Control L. I'm going to copy. Go to my Python file. I'm going to copy here, and then I'm going to paste. I'm going to clean this. Then also here where I'm going to put the attack package files, I'm going to delete here. All right, so here, so I'm going to delete this one. Now I'm going to go and get the respective name of the log. Log is attack log.txt. So attack log.txt. The first one is attack log.txt. So attack log.txt. That is the log for the Hatchetman attack. Then the package file is attack.package. Attack.package. Save it. So let me go over it and see. Let me go over something and see. No. Let me attack.package. Okay, perfect. So let me go over it. All right. Perfect. So I'm going to come over here. I'm going to launch the terminal from the directory where I have my Python file. So I'm going to open in terminal. Let me clear the screen. Then I'm going to say Python analyze.py, and I'm going to launch it. So now it's going to run over through my package files and the log files, and it's going to tabulate all the network performance metrics for me. That is how I coded the Python file. So when you buy my book, you are going to have access to both the Python file and the C file to enable you carry out this simulation yourself. So we wait for it to tabulate, all the network performance metric for us, as well as visualize it. We are going to see it on the screen in a moment. So it's going through the package files and the log files that we captured, both the reference and the attack simulations. We are still waiting. Okay, perfect. So it has done. Perfect. So wow, so we can see it for the PDR with attack. We can see that there is more packet delivery ratio is higher with attack than without attack. So I don't know why. We're expecting the VDR to be lower with the attack. I'll go over to the Python part to make sure that I substituted the right way. I put the right, I I put the that place where I put the absolute part of the backup files and the well, let's see the other metric. Average end-to-end delay, it is higher without attack. So I don't know why. Overhead packet higher without attack. Energy consumption is also higher without attack. Throughput is higher with attack. So I don't know, let me go over to the Python file. Let me go over it. Also here we have the PDR without attack. We have lesser PDR, average end-to-end delay, overhead packet, and throughput. So let me go over it to make sure that I did this thing correctly. I substituted it correctly. So log file with attack. Home Faisal videos YouTube attack log.txt. Log file without attack. Log file without attack. Log file without attack. Reflog.txt. Fuckup file with attack. Fuckup file attack with fuckup. Home file with attack. Fuckup file. So I don't know why. So that is why we just did one simulation. We can do as many simulations as possible, and then we can be able to analyze. But normally we should have lesser VDR with attack, packet delivery ratio, lesser VDR with attack, more average end-to-end delay with attack. Here we are having it more without the attack, and then also the overhead packet. Without attack, we are having more overhead packets than with the attack. Energy consumption, throughput 0.31, 0.23, 0.31 and 0.23. Also throughput, we are supposed to be having lesser throughput with attack than the one without attack. So we can perform normal simulation. So in the next video, we are going to see we can perform carry out another simulation and see what we are having this result. That is, perform more simulations with varying number of malicious attackers and then see the effect of the attack. But here I don't know why the result is the other way around. Yeah, so I'm going to conclude this video now, and then we will meet in the next upcoming tutorials. Thank you very much.